Hope you already get it what I will discuss about today, the atomic radius and ionization energy. So how to calculate that atomic radius actually? If you are given a unimolecular atom like potassium, you cannot even see optical microscope that distance of atomic radius. So how can you calculate? So you need to put potassium atoms another side to side of that potassium atom, scope the distance from this nucleus to this nucleus, and if you put that value equal to a and then you just divided it by 2, you will get that distance from here to here, and this is the one way to calculate the atomic radius. Now I will discuss about what is the main reason or role in periodic table of atomic radius. Now I will discuss about what is the role of atomic radius in periodic table. Let me draw a periodic table. I am a bad drawer, so do not blame me. Here you can see period. So here you can see the column. So if this is the periodic table and you will get down through that column, you will get the bigger atomic radius atom. But why? Let me explain it. If you put that hydrogen here, lithium here, sodium, potassium. So here you can see that the atom size like this. One thing you can notice that hydrogen has one shell, lithium 2, sodium 3. So one thing is increasing is the shelling number, and this is the way you need to know that the atomic radius is also increasing with the shell number. So if you go through that direction, I mean get down column, you will get bigger atomic radius atom, and if you get through left to right in a period, you will get a smaller atom. So why it is happening? Because if you just let sodium period 3 period, sodium, magnesium, aluminum, you can see that sodium has 3 shell, and also magnesium has 3 shell, and it is also for aluminum. So you can see that the shell number is not increasing, but what is happening actually here, the electron number and the proton number. Sodium has 11 electron and 11 proton, magnesium has 12 and aluminum has 13. So one thing is increasing is proton and electron. So when proton and electron are increasing, their bonding energy also increase, so they contract each other. That's why the increasing number of proton and electron making the atom more smaller. That is the why behind of go through left to right and you will get a smaller atom. I hope you get the role of atomic radius in periodic table. Now ionization energy. So I will make fun of it, but how? So if you want to steal or remove any electron from any outer shell of an atom, you need energy. So this energy is known as ionization energy, and this time you just make fun of it, but how? Let me explain by an example here. If you just remove or snatch any bag from two men, like one is weak and another is strongman. So if you want to snatch the bag from them, for weaker one you will need low energy, but for a strong one you will need high energy. So this is the reason behind of weak atom you will have lower ionization energy, and for a strong man you will need higher ionization energy to remove the electron from its outer shell. So what is the rule of ionization energy in periodic table? Let me draw a periodic table here. I told you I'm not a good artist. So if it is like that, I'm just drawing, do not take it seriously. So if it is a periodic table and you go through down of an column, you will have lower ionization energy. But why? So let me explain it. Hydrogen is here, lithium, sodium. Let me explain it by this two men. I hope suppose this man is tall and also have a long hand, but this man is small and it keep its bag like that. So when you just want to snatch that bag from that tall man, he is relaxing with just like that. So you can easily snatch that bag from this man, and this is also happens for sodium and also potassium here. Because of their bigger size, this nucleus has a lower attraction to the outer shell of the electron. It is like a big man who is relaxing with his hand and just holding easily his bag, and you need lower energy to snatch that bag. So when the atom is getting bigger, you will have lower ionization energy, and the smaller atom, for the smaller atoms, this atom or this man is just holding the bag like that. So if you want to snatch that bag from this man, you will have higher energy. So this time you will have higher ionization energy. So sodium has higher ionization energy than potassium, and it is also happens for the period. If you go through that left to right, the atoms are getting smaller, and for oxygen 2 minus, chlorine minus, fluorine minus, this atom seriously has a higher ionization energy. And this was the explanation of ionization energy roles in periodic table. I hope you get it. So if you get the ionization energy and atomic radius clearly, please hit the like button. And if you think this channel is useful to you, please subscribe it to get updates. Thank you so much.